This short recording is to remind you how to calculate the number of microorganisms in a sample after you've used the viable count technique. This technique is widely used as a method for estimating the number of viable microorganisms in a sample, and it's done by serial dilution and then plating samples. When you incubate your plates, you'll find that you have some plates with far too many colonies to count, and you may have some with no colonies at all. So you choose a dilution that gives you a plate with between 20 and 200 colonies, and that should allow you to count them all accurately. My example is an environmental sample, so you can see that you've got a whole range of different microorganisms on the plate, and I've counted that there are 85 colonies. So I've recorded that result in the table here. The left-hand part of the table shows you the dilution, and it's normal to do serial 10-fold dilutions, so you've got 1 in 10, 1 in 100, 1 in 1,000, etc. Now I've written this also as 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, because microbiologists will generally just refer to these dilutions, for example, as the minus 3, meaning a 1 in 1,000 dilution. So the 85 colonies that I counted were on my minus 4 dilution. There were in fact 7 colonies on the minus 5 dilution, and that's outside of our range of 20 to 200. On the minus 3 dilution, there were too many to count. You'd expect something like 800 or 900 colonies there. And then the minus 2 and the minus 1 was a complete lawn, so you couldn't really distinguish colonies at all. So we know we have 85 microorganisms in the sample that we plated out, and I'm now going to show you how to use that to calculate the number of microorganisms in the original sample. And I'm going to give you 2 different ways of thinking about this. First of all, sort of step-by-step approach. So we have 85 in the minus 4 dilution, and if you think about it, that means there should have been 850 in the minus 3 dilution, 10 times more, 8,500 in the minus 2 dilution, and now I've written that as 8.5 times 10 to the 3 because that actually makes the next step simpler. Another 10-fold, 8.5 times 10 to the 4 in the minus 1 dilution, and 8.5 times 10 to the 5 in our original sample. But that's 8.5 times 10 to the 5 in whatever volume we plated out. So let's assume that we plated out 100 microliters. But we actually want to express the final value per mil, and 100 microliters is 1/10 of a mil, so we've got one more 10-fold multiplication. So we had 8.5 times 10 to the 6 colony forming units per mil in our original sample. Why is it expressed as colony forming units per mil? It's just a very precise way of saying what you've counted. You've counted things which were capable of forming colonies in the conditions that you used for growth. If you prefer to think about it as a calculation, then you've got the count, the number of colonies on your plate, and you need to take into account the dilution factor. That will give you the number of microbes in the sample that you plated, but remember that you also need to take into account the volume plated. So in our example, we had 85 colonies on our 10 to the minus 4 dilution, so 85 times 10 to the 4 gives us 850,000, or 8.5 times 10 to the 5 colony forming units in that sample that we plated. We plated 100 microliters, which is 1/10 of a mil, and so we multiply by a further 10 times to give us 8.5 times 10 to the 6 colony forming units per mil. So to recap quickly, in that calculation you've got your count, you take into account the dilution factor, and you take into account the plating volume to give you the final colony forming units per mil.